Good morning, everybody. I am Sindhusha, working as Assistant Professor in Civil Department in Godavari Institute of Engineering and Technology. So in today's lecture, I'll be covering about the general layout of wastewater treatment plant. In this, I'll be telling you about the characteristics of water, total solids, and the classification of total solids, and the units present in a wastewater treatment plant and different types of settling. To begin with wastewater. So how do we decide whether the water is waste or for what purpose can it be used? Like, can it be used for drinking or for gardening or for construction purpose? So it is based on the quality. We are going to decide for what purpose water can be used. So what decides the quality is the characteristics. So based on the characteristics of the wastewater, we are going to define the quality of the water. So coming to the characteristics, this can be broadly classified into three types: physical characteristics, chemical, and biological characteristics. So physical characteristics of water include turbidity, color, odor, total solids, temperature. So all this with the sense you can tell it. Odor is nothing but the smell, temperature, using thermometer you say it, and color using Hazen scale you can tell, and it also includes taste. So coming to total solids. So here the total solids are again classified into two types. So in water, there are two types of solids present. One is total dissolved solids and suspended solids. So the difference between these two, in general, if we see as the name itself tells, suspended solids are nothing but the solids that are just present in the water in suspension. So these can be seen through a naked eye. For example, if you take a beaker of water and turn on a torch and see the light passing through the water. So there are some particles that are going to oppose the passage of light. So these are the particles that we are calling suspended particles. Coming to dissolved solids. So these cannot be seen through a naked eye. These are completely dissolved in the water. So we can tell that, like, how can we differentiate them is, like, if you take a filter paper whose pore size is 2 microns, so and you let this sample pass through the filter paper. So if the particles are settled on the filter paper, this 2 microns is nothing but the diameter of the pore. Pore size is 2 microns, a micrometer. So when you are allowing the sample to pass through the filter, so the particles that are going to retain on the filter paper, these are nothing but the suspended particles. So the particles that are going to pass through the filter paper, this 2 micron filter paper, those can be defined as the dissolved solids. And turbidity. Turbidity is one more physical characteristic. So turbidity is nothing but water clarity in the streams, rivers, lakes, and the ocean. Turbidity is nothing but, just now we have seen an example of taking a water sample in a beaker and allowing the light to pass through it. So what is happening? The whole light that is entering the beaker and the light coming out is not the same. Definitely, some of the light is getting reduced. This is happening because of the suspended particles present in the water sample. So what are these particles doing? They are not allowing the light to pass through. They are acting as an opaque particles, opaque objects, which are restricting the light to pass through the beaker, light to come out from the other side. So this is nothing but turbidity. Turbidity is mainly caused because of suspended solids only. Turbidity describes the amount of light scattered or blocked by the suspended particles in the water sample. So from this, we can say that clear water, if you are taking clear water, it means that suspended particles present in this clear water are very low. It means this clear water has low turbidity. And if you take any wastewater or sewage water or any effluent, so that is going to contain large number of suspended particles, that we can tell that wastewater is going to have high turbidity. So the difference between sewage and effluent is nothing but the wastewater coming out from domestic households, from houses, municipal wastewater. All this is termed as, this type of wastewater is termed as sewage. And effluent is nothing but the wastewater coming from industries. So that is the difference between effluent and sewage. And when you're considering a treatment plant, the wastewater, it can be sewage or effluent that is entering into the treatment plant. We call it as influent. And after the treatment is done, the wastewater that is going to come out to be disposed or to be reused, this water we call it as effluent. So this is about total solids and turbidity. These are physical characteristics. Next one, chemical characteristics. Chemical characteristics are because of the compounds, because of the chemical compounds that are present in the water. So the example of chemical characteristics is chemical oxygen demand, nitrogen, phosphorus, chloride, sulfates. It also includes alkalinity, acidity, hardness. All these are caused because of some compounds being present in the water. These are chemical characteristics. And the third characteristics is biological characteristics. This is completely because of the presence of microorganisms. So biological characteristics include biochemical oxygen demand, dissolved oxygen, and all. BOD is nothing but the amount of oxygen that is required by the microorganism. So coming to the treatment, there are three types of treatment: physical treatment, chemical treatment, and biological treatment. In physical treatment, through natural actions, through natural phenomena, the treatment is being happened. In chemical treatment, use of additives. You are going to add some chemicals to your wastewater to remove some particular impurities. So here you are adding chemicals, or you can call them additives. So this is chemical treatment. Third treatment is biological treatment. So in this type of treatment, you will be using microorganisms. So what are these microorganisms going to do is, they are going to decompose the matter. They are going to consume the pollutants present in the wastewater that we don't require, and they are going to purify the water. So we are having the wastewater. Biological treatment, we mainly go for biological treatment if the water contains more organic substances. So these microorganisms are going to decompose those organic substances. And after that, after the complete pollutants are removed, then these microorganisms will not be having food to survive, and oxygen also will not be available for them. So they're going to die. And finally, we can remove these microorganisms by using different types of filtration techniques. So this is the outline of a wastewater treatment plant. So there are different units. Each tank has a specific function or specific role to play. So at every particular tank, at every particular unit, some impurity is getting removed. So here if we see, initially the waste, I've just told you, primary treatment, secondary treatment, and tertiary treatment. So initially, primary treatment. What happens in primary treatment is mostly usage of screens. What are the screens going to do is, they are going to remove the larger particles from the wastewater. Next one is equalization tank. The role of equalization tank is to maintain the uniform characteristics throughout the water. So in equalization tank, we are just letting the water stay for a long period of time, so that at one point or one part of that unit, all the characteristics are not being stagnated. They are going to be uniform. The characteristic, each and every characteristic is going to be uniformly spread. Next one is primary settling tank. This can also be called as a sedimentation tank. It can be called as clarifier. So what happens in primary settling tank? So this primary settling tank, equalization tank, and bars, screening chamber. So these three come under primary treatment and also physical treatment. So what is happening here? You are not adding anything. For example, if you take primary settling tank, I told you it is also called as sedimentation tank. So what happens in this tank is, the water is moving from equalization tank to primary settling tank. So here we'll be leaving the water for some time. So what happens in primary settling tank is because of natural action, which is nothing but gravity. Because of gravity, the particles, the suspended particles or the bigger particles that are going to settle down at the bottom of the settling tank. So this is happening only because of gravity. We are not adding anything. We are not adding any chemicals. We are not adding any microorganisms for decomposition and all. So this is physical treatment. So the settled down particles or the waste particles or materials that are going to settle down in the sedimentation tank is called sludge. So in the sedimentation tank, the settling can happen in 4 types. Discrete particle settling, flocculent particle settling, hindered or zone settling, and compression settling. So first, type 1 settling. Here what is happening is each individual particle is going to settle down because of its weight, because of the action of gravity. Coming to the second type, flocculent settling. So there is a chemical or additive that we are adding into the wastewater. Here, if you see, there is a coagulation and flocculation tank. So what is this tank? What does this do? In primary settling tank, the particles which are having some weight are going to settle down. What about the remaining suspended particles? They'll be suspended in the water. They do not have any weight so that the gravity can act upon them and they can settle down. So for this purpose, we'll be adding a coagulant. Coagulant, what it does is, it brings together all the suspended particles. Each individual suspended particles is coming and forming a flock. So as each particle is not having any weight, so all this coming together, they're getting agglomerated. So this agglomerated flock is going to possess some weight. So, and now the gravity is going to act upon this particle, the bigger particle that has together all the tiny particles. So now this is going to settle down. So this is the purpose of coagulant. So most commonly used coagulant in treatment plants is alum. Alum is nothing but aluminum sulfate, and ferric chloride can also be used. These are coagulants. So coming to the second type of settling, after adding a coagulant or flocculant, what is happening? It is forming into an agglomerated mass. That means many suspended particles together are settling down. This is nothing but flocculent particle settling. This is second type. And the third type is hindered or zone settling. Here what happens is, one particle is having some weight and it is moving downwards because of gravity. So there are some other particles, suspended particles in between them. So it is at a distance of some x from the bottom of the tank. So while this is traveling to the bottom of the tank, in between the suspended particles, which might not settle down, which might not have the weight to settle down. So this bigger particle is going to take down those smaller particles to settle down. This is nothing but hindered or zone settling. Hindered is nothing but, the meaning of hindered is hide. So the particles, suspended particles that are hiding, are going to be taken by this bigger particle which has some weight, and all this is going to settle down. This is the type 3 settling. And the next one is compression settling. So here in this type of settling, the suspended particle concentration is very, very high. Here the concentration of the particles is so high that the sedimentation can only occur through compaction of the structure. So each individual suspended particle is in contact, direct contact with other particles. So they're together, everything is together, and they're going to settle down. So this is about sedimentation tank and the type of settling that is going to happen in a sedimentation tank. So in the next lecture, we'll be seeing about the remaining treatment plants in detail. So that's all for today. Thank you.